Hello everyone, so I finally decided to make a video on discrete probability. Well, this is going to be like a part 1 of discrete probability where I go through PMF, mode and median, and with a lot of exam style questions thankfully, so stay tuned for that. And I will also try to provide the marking scheme for those exam style questions to give you a brief idea of what the examiners are looking for when they check your paper. Alright, so let's begin. Discrete probability relates mostly with whole numbers in terms of when calculating the probability. Now remember, whole numbers. If you didn't understand, don't worry, I'm going to make myself clear by doing those exam style questions and also example questions that I have set in the video. Common types of questions to be seen with this area of probability, this discrete area of probability mainly involves probability mass function. Now what is probability mass function? Well, this is what exactly probability mass function will look like. Now the rows and columns will vary, the amount of rows and columns will vary, but this is the basic gist of what probability mass function is. Now, well, this x over here, let that be a random variable to represent how many times you touch grass this week. Yeah, pretty common issue in teenagers, but anyway, well, now it could be once, twice or thrice. We can't touch grass 1.5 times a week, can we? So it has to be once, twice or thrice or any of the whole numbers, etc. Now, what does this A, B and C represent? Well, A, B and C are the probability. So probability that you touch grass this week once is A, 2 is going to be B, 3 is going to be C, and so on and so forth. And there are a couple of rules to this PMF, one of them being that A plus B plus C has to always equal 1 because probability always add up to 1, so pretty self-explanatory. Now second rule is that A, B and C must be greater than or equals to 0. Probability can be 0, but it cannot be negative. Just keep that in mind. Now, one more rule I forgot to mention about here is that A, B and C cannot be greater than 1. Obviously, because, well, probability cannot be greater than 1. So those are the 3 rules that you need to keep in mind while you do this question. Alright, let's continue with this exam style question 1. So a biased coin which has a probability of 0.6 to get a head and probability of 0.4 to get a tail was tossed twice. Okay, let x be the discrete random variable to represent the number of heads tossed. Alright, so we have to complete this PMF table below. Okay. The x equals to 0. Now what does this 0 mean? That there is no heads tossed twice. So PR of x equals to 0 is simply saying that find the probability of getting tails both of the times. That would just be 0.4 times 0.4. That would be 0.16. So 0.16. Probability of tossing one head. So that would just be probability of x equals to 1. That would equals to probability of either tails first then a head plus probability of heads first and then a tail. So you can simply do 2 times 0.6 times 0.4 because at the end of the day you're just timesing them both by the same digits but in different orientation, so it doesn't matter. Now that would give you an answer of 0.48. 0.48. And probability that x is equals to 2, meaning that you toss heads twice, is going to be probability of heads plus heads is just going to be 0.6 squared, which is going to be 0.36. 0.36. Okay, now let's quickly do some checks before we move on. So how do I know these answers are correct? Well, first thing is we can say that this is all positive. The probability of every single outcome is positive, so that's always a good sign. So that means we are partially correct, we are on the right track. Now how else do I confirm that this is the right answer? Well, let's add up these probability up and see if they all add up to 1. So what is 0.48 plus 0.16? Well, that's 0.64, and plus 0.36 would be 1. So our answers are correct. Now what is the marking scheme over here? This is 3 marker question, so there will be 1 mark for all of this working out and 2 marks for 3 correct answers. Alright, now the next question is find the probability that at least one head is observed. So at least one head leaves with PR of x equals greater than or equals to 1. So at least one head could mean they need at least one head. It could be more than one, but they at least need one. So x has to be greater than or equals to 1. Okay, we can say that probability of x greater than or equals to 1 is also probability of x equals to 0, right? Because what I'm looking for is probability that of x is greater than or equals to 1. So here to here, so 0.48 plus 0.36, or you can just say that I'm going to subtract probability of x equals to 0 from 1. Both of them would still give you the same answer. Or you can alternatively just add them up, so probability of x equals to 1 plus probability of x equals to 2. Let's try both methods out. So what is 1 minus probability of x equals to 0? So probability of x equals to 0 is just going to be 0.16, and that would equals to 0.4. Now what is probability of x equals to 1? 0.48, and plus what is probability of x equals to 2? That would be 0.36, and if this added together, we'll get 0.84. Alright, so as you can see, no matter what method you prefer, both of them still give you the correct answer. Now what is the marking scheme again? This is 2 markers, so there will be 1 mark for either writing this or that, and then correct answer. So these are your 2 marks secured. Alright, so let's now move on to exam style question number 2. So Jackson goes to office 3 days every single week. Okay, to get to his office, Jackson has option to either catch a train or a bus to get there. Let t be the random discrete variable to represent the number of days he catches the train. Okay, the first thing we have to do is to find the value of k, obviously using this PMF. So how do I find the value of k? Well, we know that all of this probability would add up to 1, so we can use that to find the value of k. So k plus 2k plus k on 2 plus 3k would be equals to 1. Okay, let's add this up, so that would give us 6k plus k on 2 equals to 1, which would give us 13k on 2 equals to 1, implying that k is going to be 2 on 13. Now again, what is the marking scheme? Well, it's a 2-marker question, so 1 mark for showing your understanding, writing this, that you understand that all probability add up to 1, and the other mark for the correct answer. Okay, let's move on to this question now. So calculate the probability of t greater than 2 given that t is greater than or equals to 1. Well, this is a conditional probability type of question. If you don't understand what conditional probability is, I have explained it, so just visit my channel and find introduction to probability video. I'll put the link also in the description down below for that video, so if you want to check out, feel free. Anyway, probability of t greater than 2 given that t is greater than or equals to 1 can also be written as probability of t is greater than 2 intersecting t is greater than or equals to 1 divided by probability of t is greater than or equals to 1. Now, this is just applying conditional probability formula. It's nothing new or fancy. Let's look at how to simplify this thing over here. This right over here is quite easy. You just look at the PMF and work it out. But what exactly does this highlighted part mean? Well, let me break it down for you. So t is greater than 2 intersecting t is greater than or equals to 1. Well, this, if I read it off, it's just going to say find the probability that t is greater than 2 is intersecting t is greater than or equals to 1. How do I find that? Well, easy trick, just draw a number line. What you can do is draw this ray, so this is going to be t is greater than 2, just draw the number lines using your knowledge of math, and this is going to be t is greater than or equals to 1. So now we have to find the intersection part, right, as it wants to say. So intersection part over here, so we can clearly see that they intersect starting from this value. So here is the point where they start to intersect. Now what is that point? Well, that is simply just going to be probability of t is greater than 2, right? Pretty self-explanatory, right? Pretty clear now. This visualization should hopefully help you to understand what's going on a bit further. So we can say that this is also equals to probability of t greater than 2 divided by probability of t greater than or equals to 1. Okay, now let's try to find the probabilities of this individually. So probability of t greater than 2 is just simply going to be 3k. Well, because t greater than 2, we only have 3 over here that is greater than 2, so it's just going to be 3k. Say if there was a 4 here, then add up that probability as well, but since there is no 4 and only 3, it's just going to be 3k. And probability of t greater than or equals to 1 can also be written as 1 minus probability of t equals to 0, as discussed earlier, which would be 1 minus k, right? 1 minus k. And let's divide these two now. So 3 over k divided by 1 minus k. And let's sub in what k is. So 3 times 2 over 13 divided by 1 minus 2 over 13. So this should give us 6 over 13 divided by 11 on 13. And when simplified, we will get 6 on 13 times it by 13 on 11. Cancel, cancel. And there you go. 6 on 11 is your answer to part B. Now, this is a 2-marker question. So where are our 2 marks? So one is obviously for the correct answer. The second one is just basically understanding and realizing that this over here could be written as this as well. So that shows your understanding of probability and a bit of number line. So that's your second mark over there. Okay, now let's approach question C. It is very similar to question B, as you can see. It's just that the signs have changed. Nothing else did. So again, we can write. Okay, now again, let's look at how do I break this part down. So number line OP, just draw a number line. T is greater than 1, so this is T is greater than 1, and T is less than 3. This is our T is less than 3. And what we are finding here is we are finding the intersection. So we're looking at this part over here. And where is that part? Well, that would just imply that this part over here is just going to be what? Probability of 1 less than T less than 3. Right? It's just between 1 and 3, but 1 and 3 are exclusive because it's an open circle. So there you go. That's your visualization done and dusted. Now it's going to be really simple to do this. So that would also equals to probability of 1 less than T less than 3 divided by probability divided by probability of T less than 3. Alright, now probability of 1 less than T less than 3. So 3, so it can't be this one, it can't be that, but it has to be between 1 and 3. That leaves it with only one option, which is 2. So what is the probability that is between 1 and 3? It's just going to be probability of 2. So probability of 1 less than T less than 3 equals to probability of T equals to 2, which is just equals to K on 2. And what is the probability of T less than 3? Well, T less than 3 is everything over here, or probability of T less than 3, which can also be written as 1 minus probability of T equals to 3. So what I'm doing is, rather than adding all of these up, I am just going to subtract one. I'm just going to subtract this 3k from 1, because all the probability add up to 1. I know that, so that would make my life a lot more easier. And now if we were to divide that, so this would firstly give us answer 1 minus 3k. Now let's just divide these two. So our answer finally would be k on 2 times 1 minus 3k. And let's substitute our k in now. So 2 over 13, sorry, divided by 2 times 1 minus 3 times 2 over 13. That would give us 2 over 13 divided by 14 over 13, and that would be 2 on 13 times 13 over 14, which would cancel out and give us 1 on 7. So this is our probability. This is the answer to this part C over here. So where's our marks again? This is 2 marker. Again, this entire part that you realize that it's just going to be this series of sequence, and you know that this turns into that, and 1 mark for the answer. So 1 mark over here and 1 mark over here. And there you go. That's your exam style question number 2 done and dusted. Alrighty, let's move on with median and mode. So what exactly is median? Well, it's the same thing that you have been learning from all these years, that median is the 50%. Median is the value at the 50% of the data set. It's nothing different over here as well. And mode is the most repeated number in the data set. Same thing over here, except mode will be the number which has the highest probability. Well, because if it's highest probability, then it's going to be more frequently appearing. So that's the basic gist of what median and mode is. Nothing different, but yeah. Alright, let's attempt this question to further strengthen your understanding. So, find median and mode of this following probability mass function. So, alright, let's start with the first one. Let's start off with median. So, this is 17%. Probability of x equals to 0 is going to be 17%. X equals to 1 is going to be 23%. 2 is going to be 30%. 3 is going to be 30% again. Okay, now let's add 17% and 23% up. So I'm going to add these two up, and that will give me 40%, right? Again, we are looking for 50% mark. So this 40% is still not quite to the 50% mark yet. So what I'm going to do is add another 30 from here, and that will make it 70%. So we can clearly see that median is somewhere going to be here. Between these two values, one over here and one over here, is going to be somewhere in middle, right? But here, this is discrete probability. So we don't care about what the middle point is. We don't care about all the decimals and stuff. What we can simply conclude here is that median is just going to be 2, because 50% mark falls under 2. So median is going to be 2. And mode, again, is the most repeated number with the highest probability. So these two over here have highest probability. So it's going to be 2 and 3. We have two modes here. But yeah, alright, now let's move on to this other PMF. So again, PR of x equals to 0 is going to be 35%, 1 is going to be 15, 2 is going to be 5%, and 3 is going to be 45%. Now, let's add these two up. So let's add these two up, we'll get 50%. Okay, so 50% lies right over here. It does not lie between 0 and 1, because as we add 0 and 1, exactly then right after we get 50%. So it's going to be right on this line over here. Now, how do I find median over there? Well, since median is between 1 and 2, dead center between 1 and 2, what we can do is just take the average like we do to find midpoint and stuff. So we just add 1 plus 2 divided by 2, and we'll get 1.5 as our median. And mode, very simple. The most repeated number, so the highest probability, is just going to be 3. And there you go, that's your entire part 1 of discrete probability done and dusted. Hope you found this video useful. I will upload part 2 of this video, where part 2 of discrete probability, where I cover mean, variance, standard deviation, all the other complicated stuff. But thank you all for watching at the moment. I hope you found it interesting, and I'll see you in the next one. Bye bye.